Hello, today we're going to learn about sets. And a set is a well-defined group of objects or symbols. The symbols and the objects in the set are called elements. So for example, if we have a set of fruits, right, and we want to name some fruits that we can put into the set so they belong to the set. We can name bananas, we can name apples, we can name oranges. This is a set of fruits. Or let's say, even if we started with these things and we're trying to group them into a set, these are fruits, and we can call that a set of fruits. So even if we're going to talk about shoes, t-shirts, caps, we're going to talk about pants, then that's a set of clothing, right? So anything that belongs to that group of clothing becomes the element. So these are the elements of a set of fruits. Now, if we're working or with a worked example, and we're given here, for instance, set A is a set containing natural numbers, right? Write down two elements of this set. Natural numbers are 1, 2, 3, 4, 5. Those are our natural numbers. So I can write anything. I can write 3. I can write 15. Okay, so we learned that a set is a well-defined group of objects or symbols, and the symbols in the set are called elements. So we're going to learn about what a subset is. A subset is just a set within a set. So for instance, I know that sounds confusing, but let's bear with me. Let me just explain. Now, here we have set A, and set A is natural numbers under and equal to 10. And B is a set of even numbers. Now, if A is a set of natural numbers under 10 and the even numbers are in B, B is a subset of A. That means we're going to write all the even numbers that are under A in B, meaning all the even numbers that are under 10 in here. So that means if I'm going to say 1, I'm going to say 2 in there, 3, 4, 5, 6, 7, 8, 9, and then 10. So now, as you can see, I have all my even numbers in here and all my odd numbers in there. And all of these numbers are numbers under 10, and then they're still within the big set of A. Okay, we're going to be talking about subsets. And we learned that subsets are just sets within other sets. So for instance, another way to write if something is a subset of something, you say Q and you put the symbol, meaning Q is a subset of P. Now, if P is whole numbers less than 30, and then now it says Q is a set of prime numbers. Now we know if Q is a subset of P, these are going to be prime numbers under 30. So let's list some of the prime numbers that we can find under 30. Let's move. What are the prime numbers? 2, 3, 5, 7, 11, 13, 17, 19, 23, and then 20. Is there any other 20? 29? 29, yes. And then, yes, that's it. So these are the subsets. If I'm wrong, please correct me in the comments, but these are the elements that belong to Q, which is a subset of P. Okay, now we're going to learn about the Venn diagram. And Venn diagram is, I hope I don't say it wrong, a principal way of diagrammatically showing sets. So it's pretty much drawing sets and putting set information in a diagram form of it. So I've drawn here a universal set. It's not going to be needed in this particular question, but I drew it so that I can introduce it to you. When you see something like that, that means it's a universal set. And within it, we have subsets P and Q, right? P and Q have an overlap, and I'm going to explain where that overlap is coming from in a minute. Okay, so you see over there we have P, and you also see over there we have Q. Now, in P, we have 3, 6, 9, 12, 15, and 18. That means this is just a set of multiples of 3 until you get to 18. And then in Q, we have 2, 4, 6, 8, 10, and 12, which is also just even numbers, multiples of 2 until we get to 12. So pretty much the first 6 multiples of 2 and the first 6 multiples of 3. So now we need to put this information and present it onto our Venn diagram. Now, before I present that, this overlap just is there to represent that there are some elements that will be in P at the same time as they will be in Q. So this overlap is called the intersection. This overlap is called the intersection. So all things that move there are in the intersection. And then union. So that's intersection. And then union are all things that are in P and Q. So when we unite P and Q, all the elements of P and all the elements of Q all together, that's it. So it will be a set. So when you say union, we are now redefining a set, the set P and Q to become one, where all the elements that are in P and all the elements that are in Q satisfy that set. Now, if we look over here, we'll see that outside the Venn diagram, we'll talk about that in the next episode, where we see that what we call the set in which everything that's outside of P and Q, or everything that is outside of P, or everything that is outside of Q. So now let's move on. Okay, now we're about to put the information here. So yeah, let's start off. I usually try and start off by filling the middle area so that I then don't get carried away. So firstly, I know which ones are overlapping. 6 is in here, 6 is in here, and then 12 is in here, 12 is in here. So 6 and 12 are in the overlap, are in the intersection, and then now I can just fill in the rest. 9, 12, no, 12 is already in there, 18 and 15, and then here I come here, I say 2, 4, 6, 8, 10, and then 12. So now, as you can see, this is how I correctly and properly put this information displayed on my Venn diagram. Okay, so right now we're going to learn about complement. What does it mean when you're talking to, all right. Okay, right now we're going to learn about complement. What does complement mean when we are talking about sets? So here I have drawn a universal set, and the universal set is a set of numbers between and including 1 and 10. And within it, I drew a subset, which is A, which entails a set of group of numbers that are even numbers, right? So before I start to fill it in, I'm going to show you what complement means. When we say a complement, which is represented by that, a complement just means everything outside of A. So meaning this is what satisfies, the shaded region is what satisfies a complement. Now, when we're talking about a complement in this regard, we're going to put everything that satisfies A in here. 2, 4, 6, 8. And then we leave everything else out. 1, 3, 5, 7, and then 9. And then 10 also goes in here. So if I'm coming here and I'm now writing the elements that belong to the set A complement, I'm going to write things that are outside, the things that are in the universal set and not particularly in A. So I'm going to write 1, 3, 5, 7, and 9. All right. That's how it's done. Okay, now that we know what a set is, what a subset is, what a universal set is, what complement means, what intersection means, what union means, if you're not sure what these things mean, you need to rewind the video or look for another video where I explain these things. But now that we're sure that these things, or what these things mean, let's move on and let's try working out this example. This is a universal set. So it says, what are the elements of the universal set? Another thing, another trick before we move that I can teach you about universal sets, or actually about sets. When you see anything with an N and A, I hope you can see it. My marker is dry now. N and A, it means what are the number of elements in set A. So for instance, if you see something like this, N brackets A, that means what are the elements in here? So we come here, we count the elements, 1, 2, 3, 4. And we see that the answer would be 4. Okay, so let us find the elements that are or make up the universal set. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 1, 2, 3, 4, 5, 6, 7, and 8. And we close our set. Now it says here A complement. So that means everything outside of A. So that excludes 5, 7, 2, and 3 because those are within A. So everything that's outside of A, that's 1, 8, 4, 6. If you disagree with anything that I'm doing, you just let me know. I'm not a machine, but I'm close. I'm kidding. Anyway, A union B. Actually, that's wrong. A, this is intersection. So if the cup is facing down, that's intersection. If the cup is facing up, that's union. That's how I remembered it. I hope that helps. But anyway, A intersection B. So that just means I'm going where A intersects with B. The elements are just simple. 2 and 3. I close my section. Then I come down here. Right? A intersection B complement, meaning everything outside of this area. So this one helps me understand the C helps me understand D better because I know what C is and I know what's not C. So whatever is not C, which is everything outside of the intersection. So now we come here, we draw our 1, and then we leave the 2, we leave the 3, we jump to 4, we jump to 5, we jump to 6, 7, and 8. Then we close our set, and then finally A union B. That's just simple because it's everything minus 6, because obviously we're talking about everything in A and everything in B living together as one. 1, 2, 3, 4, 5, and then 7, and then 8. I hope this was helpful. If it was, please comment. And if it wasn't, tell me again what you need me to do, and I'll do it. I might not do it, but I'll try. I'll see. I'll read the comments. I might. I don't know. Don't know. I'm just saying a lot of things. But thank you for watching. This has been Sits with me.